Good morning, sir.
Morning.
Good morning, sir.
Morning. So can you see my screen?
Yes, sir. Yes,
Yes,
sir.
sir. Okay, so in the last class you see I have solved problem number 17. Right? So that can be solved by using S shifting, but here we have applied the notion of derivative. This one. It is problem number what? Uh, 17. Okay, one more I am showing related to derivative. Like t cos 4t. Okay, t cos 4t. Otherwise, okay, I'm telling you the idea. You just do it. I will not do it. Is similar to that 17. Here, first of all, you think, can you apply any other formula except differentiation? Can you apply any other formula? S shifting not possible, right? In case of problem number 16, S shifting theorem, it is not possible to apply. Do you get it or not? Means in case of S shifting, the form of the function should be e to the power at into ft, and it is not in that form, e to the power at into ft, right? And there are no tabulated formula also for this. So you have to apply some other formula, other type of formula. So here you can apply the derivative. Now, can you tell me how many times I have to differentiate it and then need to take Laplace transform? How many times differentiation? For problem number 17, number of differentiation 1. We have differentiated one time, right?
Yes, sir.
I told now why I have differentiated only one time.
Yes, sir.
So can you tell me for problem number 16, how many times I have to differentiate it?
Sir, 2 times.
2 times. Because means in first derivative, you will not get this type of term, t cos 4t. In the second derivative, you will get this term, t cos 4t related term. I told unless until you will get this given type of function, you differentiate it. Okay. So here, if you differentiate it one time, you will get t sin 4t, and some other term also will be there, right?
Yes, sir.
And if you differentiate it again, then you will get t cos 4t. So you do it. Now, in case of cos square 2t, in case of cos square 2t, what you will do? See, it is problem number 18. It can be solved easily. Laplace transform of cos square 2t. In 6.1 also we have seen this type of problem. Laplace transform of this. How to solve it? In 6.1 also this type of problem was there.
So we will write it in the form of cos 2 theta.
This problem number 4. Yes, you have to write it in the term of cos 2 theta. Means there are no tabulated formula for cos square or sin square. You see problem number 4. It is similar to that, right? So you write it in the form of cos 2 theta, then you take Laplace transform, it will be easier. But here they are asking you to use derivative. Fine. So we are assuming that ft is equal to cos square 2t. Now f dash t will be, what is the differentiation of this function? 2 cos 2t into what is the differentiation of cos 2t? Minus sin 2t into what?
2.
2. Correct. So what we are getting? Minus 4 sin 2t cos 2t. And it is actually what? 2 sin a sin a cos a as a 2 sin t cos t. Sin 2t, right? So can I write that? What is the formula for sin 2t? 2 sin t cos t, na?
Yes, sir.
By using that, I can write minus 2 sin 4t. Now you think whether I can find the Laplace transform of this sin 4t? It is possible from the table. So no need to differentiate it again. Now you take Laplace transform both sides. Therefore, Laplace transform of f dash t is equal to minus 2 Laplace transform of sin 4t. And what is the formula for Laplace transform of f dash t? Is Laplace transform of f. F means ft minus f0, right? What is f0? F0 comes from this initial function. Put t is equal to 0. It is what? 1. Cos 0, na? Cos square is 0. It is 1. Minus 2. And what is Laplace transform of sin 4t?
4 by s square plus 16.
16. So s into Laplace transform of ft is equal to 1 minus 8 divided by a square plus 16. You can simplify it. Laplace transform of ft, it is a square plus 16 minus 8 means a square plus 8. This. So that is the Laplace transform of the function. Fine. And you can use the alternative approach and you match it, whether the answer is matching or not. What is the alternative method? I'm showing in brief. So ft is equal to, directly I'm writing Laplace transform of cos square 2t. So I can write it Laplace transform of 1 plus cos 4t divided by 2, right? Then it is 1 by 2 Laplace transform of 1 plus 1 by 2 Laplace transform of cos 4t. Now it is 1 by 2s and it is 1 by 2 into s divided by a square plus 16. Now you simplify it. S into a square plus 16, a square plus 16 plus a square. So it is 2a square and divided by 2. So can it be written as a square plus 8 divided by a square plus 16 into s? Same, Anna? We are getting same answer. Any doubt? Which one is
Okay.
easier?
Sir, second one.
Second one. So if it is asked to find Laplace transform of cos square 2t, then you can apply the second. But if they ask using differentiation, you find the Laplace transform of this, then you have to apply the first. No other way. Similarly, you do for cos hyperbolic square t and sine square, same cos square sine square. Okay. Also, you try problem number 20. Now I'm showing yes.
सर वो जो फर्स्ट मेथड में सर वो -1 कहाँ से है सर?
This
Sir,
-1 Laplace
yes.
transform of f dash t. What is the formula? Laplace transform of f dash t. ये एक फॉर्मूला है ना, डेरिवेटिव का फॉर्मूला. S Laplace transform of f t minus f0. Now you see ये जो 1 है ये f0 है. ft में t is equal to 0 पुट करो तो f0 मिलेगा ना. तो f0 क्या है? 1.
Yes.
Got it?
Yes, sir.
Okay. Now 23 to 29, we have to find inverse of some kind of function of s. Okay. Now how to find Laplace inverse? You see the trick here. What is the difference with the problems given in 6.1? There was also some problems now where you have to find Laplace inverse of capital Fs. So what is the difference here? Say problem number 23. Three divided by a square plus s by 4. This. Okay. You have to find Laplace inverse of it. How to find it? For that actually there are three options. You can solve it in 3 ways. One way is that you write it s into s plus s by 4, right? then you represent it in that, sorry, it is 1 by. Then you represent it as partial fraction. And after that, Laplace inverse will be easier, no? Laplace inverse of something by s and Laplace inverse of something by s plus 4. That is one way. Now what is the another way? Another way is that you represent the denominator in whole square form. So 3 by a square plus 2 into 1 by 8 into s plus 1 by 64 minus 1 by 64. Can I write this? I'm representing the denominator in whole square form. So it is 3 divided by s plus 1 by 8 whole square minus 1 by 8 whole square. So after that, what we should do? How to find Laplace inverse? How to find Laplace inverse? It is f of s minus a form, na? S plus 1 by 8. F of s plus 1 by 8 form. So s shifting. Why are you taking so much time? For that, whenever we are representing in that form, whole square form, we should apply s shifting theorem. Right? तो यहाँ पे इनवर्स ये वाला एक केस हो गया जहाँ पे एस शिफ्टिंग यूज करके कर सकते हैं. ये एक केस है जहाँ पे डायरेक्ट कर सकते हैं. एंड another case, so we are representing it as 3 by s into s plus 1 by 4. Okay, and I am thinking it as fs by s. Can I think it as fs by s? तो fs क्या होगा?
तो 3 by s plus 1 by 4.
3 by s plus 1 by 4. That is the new one. Okay, ये जो मैं अभी कर रहा हूँ, that is based on the new formula which is given in that chapter, in that section. What is the formula here? That integration formula. Laplace transform of 0 to t f tau d tau is equal to fs by s. Or in terms of Laplace inverse, I can write Laplace inverse of fs by s. It is equals to 0 to t f tau d tau. So we are using the L inverse form, right? We are representing the function of s as f of s by s. And then you find Laplace inverse of that fs, that will be small f. And then you integrate that small f. Okay? So I am going to apply this formula. So if we apply this, what is ft here? So fs 3 by s plus 4. If we think the given function as fs by s, then our fs is 3 by s plus 1 by 4. Is it okay?
Yes, sir.
Are you getting all?
Yes, sir.
Yes, sir.
Yes, sir. Okay, now you find ft, small ft. So what is small ft? Laplace inverse of fs. What it will be? Tell me immediately. Tell me. Very poor situation. Offline students, they are studying well. They are responding actually. No, that is not a good sign. You study. Don't think that at the time of exam we will copy it. We will copy the answers and we will get full marks. Not every time. Anyone?
So e to the power minus t by 4.
E to the power minus t by 4. Yes. देखो बार बार फॉर्मूला एक्सप्लेन नहीं कर सकता हूँ. अगर पढ़ोगे तो मतलब एक बार में ही समझ जाओगे, एक बार में ही याद रहेगा. बट अगर नहीं पढ़ेगा तो मैं जितना बार भी बता दूं, that is not enough. What is the form here? The form is Laplace inverse of 1 by s minus a type. Now, what is the Laplace inverse of 1 by s minus a? It is e to the power at. So by using that, you can write if t is equal to 3 e to the power. Here a is minus 1 by 4. Okay. So it will be 3 e to the power minus t by 4. Now, ultimately, what will be the answer? It is not the answer. It is a Laplace inverse of fs. That is ft. Now, to find Laplace inverse of fs by s means the given function. What you will write? You see that formula. Laplace inverse of the given function. What I will write? Tell me. You see the formula and tell me. 0 to t integration f tau. So f tau means that is ft, small ft. अब t की जगह पे tau लिखने से f tau हो जाएगा. So 3 e to the power minus tau by 4. That is f tau d tau. Solve that integration and it will be the answer. Okay. It is what?
Yes, sir.
3 e to the power minus tau by 4 divided by minus 1 by 4 and limit 0 to t. तो ये हो जाएगा कितना -12. And if you put tau is equal to t e to the power minus t by 4 and if you put 0 it is 1. That is answer. Right? Now you try.
Sir,
Ah,
sir, can we get multiple answer by using different
no,
formula?
no. Not multiple answer. We will get single answer but in different form. ओके मतलब तुम सोच रहे हो कि ये फास्ट फॉर्म में जो आंसर आएगा सेकंड फॉर्म में कोई डिफरेंट आंसर आ सकता है.
Yes, sir.
बट दोनों को अगर सिंप्लीफाई किया जाए ना वो एक लेवल पे आ जाएगा.
Okay, sir.
ओके
Yes, sir.
डिफरेंट आंसर नहीं. So you try 25. 25. It is 1 by s into a square plus omega square. Right? By that
So
integration.
by last method.
Yes, integration formula. It's better to use that formula whenever the given function it is of the form fs by s. Okay, means you can see the pattern fs by s. You apply that integration form. What is capital Fs? If you think it as Fs by s.
So 1 by s square plus omega square.
1 by square plus omega square. Okay. So we are assuming it as Fs by s. Then so where Fs is equal to 1 by s square plus omega square. Now if I know small ft, then we can use that integration formula, right? So what is small ft here?
So L minus S ls. Uh, what is answer? I'm telling.
What is ft?
So Laplace inverse fs.
Laplace inverse of f is correct. But what is the function exactly?
Sir, 1 by a cos omega t.
Then 1 by omega sin omega t.
Yes. It is 1 by omega sine omega t. The Laplace inverse of fs means 1 by a square plus omega square. Now it is not exactly the tabulated formula.
Sir, cos.
No, in case of cos, the
तो
numerator
1 by
is
s हो जाएगा 1 by s cos omega t.
no. s कैसे रहेगा? Don't do that. मतलब ये आई थिंक तुम्हारे सेक्शन में नहीं बताया. Don't try to adjust with s. Okay.
So can't we multiply with 1 by s?
I'm telling, if you do that, okay, if you want to do that, then you means 1 by s that you cannot bring it out to the Laplace from the Laplace.
Okay, sir. Yes, sir. Yes. Yes.
एंड अगर ये कर भी लोगे तो ये एल इनवर्स ऑफ एस बाई ए स्क्वायर प्लस ओमेगा स्क्वायर, देन यू राइट 1 बाई एस कॉस ओमेगा टी. अगर ये कर भी लेते हो गलती से तो ये जगह दैट इज नॉट डिफाइंड थिंग. एक्चुअली एफ टी लिख रहा हूं तो वहां पे एस कैसे आएगा? ओनली टी का फंक्शन रहेगा एंड कांस्टेंट रहेगा. एस तो एक अलग वेरिएबल है ना, वो तो डिफरेंट, वो कोडोमेन का वेरिएबल है. एफ टी जो है वो डोमेन एंड एफएस जो है वो कोडोमेन, राइट? तो एफटी में एस कैसे आएगा? तो डोंट ट्राई टू एडजस्ट विथ एस. You can multiply or divide by some constant. That only you can do. Fine.
Yes, sir.
अदरवाइज एस से एडजस्ट कर सकते हैं तो कुछ भी हो सकता है, राइट? मतलब तुम अपने मन का कुछ भी बना सकते हो. तो ओमेगा से एडजस्ट कर सकते हैं बिकॉज ओमेगा इज कांस्टेंट, तो 1 बाय ओमेगा को बाहर लिख सकते हैं. ओके, नाउ इट इज 1 बाय ओमेगा Laplace inverse of
Sin omega t.
sin omega t. तो अभी जो गिवन फंक्शन था उसका लैप्लस इनवर्स क्या हो जाएगा, बाय द इंटीग्रेशन फॉर्मूला 0 to t। देखो अगर एफ टाउ डी टाउ नहीं भी करना चाहते हो तो कोई इशू नहीं है, एफ टी डी टी ही कर दो। 1/ओमेगा, मतलब इफ यू डोंट वांट टू चेंज द वेरिएबल टू टाउ यू कैन कीप दैट टी फॉर्म, this ft dt. Instead f tau d tau I am writing ft dt, but I told the reason behind it, why we take tau. What I told, why we take tau, because in the limit actually we have taken the variable t, that is why we don't use t in the integrand. तो बट ये लिखने से कोई इशू नहीं होगा, मतलब आंसर तो आ जाएगा। जब लिमिट पुट करेंगे टी को टी ही पुट करेंगे। सो 1/ओमेगा एंड साइन ओमेगा टी का इंटीग्रेशन
minus cos omega t
दैट्स ऑल
by omega.
yes। so if you put the limit 0 to t तो -1/ओमेगा स्क्वायर को रख लेता हूँ बाहर, एंड ये हो जाएगा, t को t ही पुट करूंगा अभी, ठीक है। फॉर द अपर लिमिट वी विल पुट t इज इक्वल टू t, तो cos ओमेगा t माइनस 0 पुट करेंगे तो 1 minus 1/ओमेगा स्क्वायर cos omega t minus 1, that will be the answer. Okay,
Yes, sir.
any doubt?
Okay.
Now if fs is multiplied by 1/a square, then what you will do? Means fs divided by a square form. Like problem number 26 I am doing. Okay, problem number 26. Better to take a harder one, it is easier. 28. I am taking 28. 3s plus 4 divided by a square plus k square square. 28 problem number. Yes, 3s plus 4. Oh.
It's s to the power.
This.
Yes, sir.
We have to find Laplace inverse of this. Now, देखो, from the denominator we can take a square common.
Yes, sir.
A square into a square plus k square.
Sir, can't we take s common and make it as fs by s?
Actually that we have to do. It is a repeated application of that formula. Means 2 times we have to apply fs by s form. Okay.
Yes.
So if we think it as fs by s, then what is fs?
So 3s plus 4 divided by s into s square plus k square.
दिस, राइट?
Yes, sir.
Yes, sir.
तो ये एफ एस के लिए एफ टी चाहिए, तभी जाके वो इंटीग्रेशन फॉर्मूला यूज होगा। स्मॉल एफ टी चाहिए। अब ये स्मॉल एफ टी निकालने के लिए अगेन यू थिंक इट एज fs by s, not fs by s I am assuming, I am taking gs by s. Okay, I am thinking it as gs by s. So what is gs here?
So 3s per 4 by s square plus k square.
Sorry, this. Now gs, what is the Laplace inverse of this? I am assuming it as gt. तो ये स्टैंडर्ड नोटेशन है, gs का Laplace inverse gt. What is gt? देखो 3 इंटू एस डिवाइडेड बाई स्क्वायर प्लस के स्क्वायर, तो ये हो जाएगा 3 इंटू कॉस के टी एंड प्लस 4 बाई के साइन के टी, राइट?
Yes,
Sir?
sir.
हाँ
सर GS by S क्यों लिए फिर से?
हाँ,
सर GS by S क्यों हुआ सर?
वो एक्चुअली देखो हम लोग ये इसका इनवर्स निकालना है ना, एफ एस का इनवर्स। तो इनवर्स निकालने के लिए ये भी तो समथिंग मतलब ए फंक्शन ऑफ एस बाई एस फॉर्म है ना। डायरेक्ट तो इसका इनवर्स नहीं निकाला जाएगा, इसका इनवर्स निकालने के लिए कुछ ना कुछ फॉर्मूला अप्लाई करना है, तो वो इंटीग्रेशन फॉर्मूला ही यूज करेंगे।
ओके सर।
और नहीं तो इसमें अगर कंफ्यूजन हो रहा है तो मैं अलग से बनाता हूँ। तो क्या करोगे, जो भी एस या ए स्क्वायर जो भी कॉमन है नीचे, उसको इग्नोर करके बाकी जो है उसको एफ एस ले लो, ठीक है? तो वी एज्यूम एफ एस 3s plus 4 divided by a square plus k square. Okay, now ft क्या होगा, इसका लैपलेस इनवर्स जैसा मैंने लिखा था 3
So 3 cos kt plus 4 by k sin kt.
sin kt. Do you need any explanation for that, how I am getting ft? You just split that part into two fraction. Okay, for the first fraction you will get this, and for the second fraction you have to adjust it by k, and then you will get it sin kt form. Okay,
Yes,
any
sir.
doubtful? अगर in details चाहिए तो मैं explain करता हूँ। ये डायरेक्ट लिख सकते हो, ठीक है? इसमें
Yes, sir.
बड़ा करके लिखने की जरूरत नहीं है, अगर समझ में आ रहा है तो डायरेक्ट ऐसे लिख सकते हो।
Yes, sir.
सर ये 5 मार्क का आएगा?
हाँ, ये 5 मार्क्स का आ सकता है।
ओके सर।
तो ये हो गया ft. नाउ first of all I am finding Laplace inverse of fs by s in the first step. ओके, तो fs को लिया है ये दिस, तो fs by s मतलब अभी किसका लैपलेस इनवर्स में निकाल रहा हूं, 3s plus 4 डिवाइड बाई s into a square plus k square, इसका लैपलेस इनवर्स निकाल रहा हूं. ओके, अभी a स्क्वायर का नहीं निकाल रहा हूं, अभी नीचे s होगा तो वो केस में क्या होगा, उसका लैपलेस इनवर्स निकाल रहा हूं. तो बाय द फॉर्मूला इट इज व्हाट, 0 to t 3 cos kt plus 4 by k sin kt dt. तो फर्स्ट ऑफ ऑल यू इंटीग्रेट इट, कॉस का इंटीग्रेशन साइन 3 बाई के साइन के टी एंड साइन का होगा माइनस कॉस, राइट. जीरो टू टी. तो if we put t then it remains same, 3 by k sin kt minus 4 by k square cos kt एंड फॉर जीरो के लिए ये टर्म जीरो हो जाएगा एंड ये प्लस 4 by k स्क्वायर रहेगा ना, दिस. एनी डाउट? टी के लिए माइनस जीरो के लिए ना, तो टी के लिए तो फर्स्ट टू टर्म्स एंड जीरो के लिए माइनस करेंगे तो फर्स्ट टर्म जीरो हो जाएगा, माइनस माइनस प्लस 4 by k स्क्वायर cos जीरो. Am I correct?
Yes, sir.
Yes, sir.
तो ये हो गया लैप्लस इनवर्स ऑफ fs by s. नाउ लैप्लस इनवर्स ऑफ, इसको और एक बार डिवाइडेड बाय s कर देंगे तो मतलब fs डिवाइडेड बाय a स्क्वायर अभी मैं चाहता हूं, यही फाइनल आंसर होगा, राइट? यही मतलब जो रिक्वायर्ड है यही है.
Yes, sir.
I can represent it as fs divided by s whole divided by s. Now it is our new fs. अब इसका जो लैप्लास इनवर्स होगा उसका इंटीग्रेशन करेंगे, fs by s का जो लैप्लास इनवर्स है उसका इंटीग्रेशन करेंगे तभी ये दैट होल डिवाइडेड बाय s मिलेगा ना. तो मतलब क्या हुआ कि प्रीवियस स्टेप में जो मिला उसको ही बस और एक बार इंटीग्रेशन कर देना है 0 to t, है ना. तो बेसिकली क्या हुआ कि a स्क्वायर का मतलब है ये 2 बार इंटीग्रेशन करना पड़ेगा, s क्यूब होगा तो ये 3 बार इंटीग्रेशन हो जाएगा ft का. तो 0 to t 3 by k साइन के टी माइनस 4 by k स्क्वायर cos के टी प्लस 4 by k स्क्वायर dt. ये इंटीग्रेशन करो, कंप्लीट करो इसको, ठीक है. एनी डाउट हियर?
No, sir.
देखो अभी ये अगर चेन समझ में आ गया तो अगर नीचे s क्यूब s टू द पावर 4 कॉमन कुछ भी रहेगा तो बस इंटीग्रेशन बार बार करते जाना है. पहले fs जो मतलब a स्क्वायर हो या a क्यूब हो उसको छोड़ के बाकी जो है वो fs ले लो. अब उसका लैप्लास इनवर्स निकालो ft, देन पहला स्टेप में fs बाई s हो जाएगा इंटीग्रेशन में, देन सेकेंड स्टेप में fs बाई a स्क्वायर हो जाएगा वही इंटीग्रेशन में, fs बाई नेक्स्ट स्टेप में fs बाई s क्यूब. अगर यहाँ पे s क्यूब रहता, ठीक है, तो क्या होता, ये जो इंटीग्रेशन आता है इसको और एक बार इंटीग्रेशन कर देते 0 to t. ओके, तो एटमोस्ट स्क्वायर रहता है, इससे ज्यादा नहीं रहता। एंड ऐसा क्वेश्चन एग्जाम में आता है, एफ एस बाई एस और एफ एस बाई ए स्क्वायर फॉर्म। ये कर लोगे ना कंप्लीट?
Yes, sir.
Yes, sir.
Okay, I'm now taking attendance. You can complete it. Roll number 742, 44,
Yes, sir.
45, 46.
45 present.
45 present, sir.
Okay, 46,
46
47,
present, sir. Present, sir.
47,
Present, sir.
48,
Sir, he wrote in the chat box, Mike, please.
49,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53,
Present, sir.
55,
Present, sir.
56,
Present, sir.
58,
Present, sir.
61,
Present, sir.
63,
Present, sir.
64,
Present, sir.
65,
Present, sir.
66,
Yes, sir.
67,
Present, sir.
70,
Present, sir.
71,
Present, sir.
72,
Present, sir.
73,
Present, sir.
75, 76,
Present, sir.
78, 79,
Present, sir.
80,
Present, sir.
85,
Present, sir.
87,
Present, sir.
89,
Present, sir.
90,
Present, sir.
91,
Present, sir.
92, 97, 98,
sir.
oh, 97,
97, sir. Present.
okay, 98, 99,
Present, sir.
801, 2,
Present, sir.
4, 6,
Present, sir.
8,
Present, sir.
10,
Present, sir.
11,
Present, sir.
12,
Present, sir. Sir, 804 is present. He wrote in the chat box.
14,
14 present, sir.
15, 16,
Present, sir.
17,
Present, sir.
18, 19,
Present, sir.
21,
Present, sir.